how do space telescopes like the Hubble Space Telescope, the James Webb Space Telescope create images? Are they accurate? A telescope usually has lenses. You have to understand optics. So it's usually lenses and mirrors, or lenses or mirrors, and you can have prisms as well. There are different kinds of telescopes. Some are just like your cameras. I don't know where's my camera. I've got a bunch of cameras. So you have something called an SLR camera or a DSLR, digital single lens reflector. So when you have a lens, a camera has a lens, right? Light comes through the lens. It's focused on an element which is a reflective element, and that it's a mirror which reflects the light onto the digital processor, and that's how the image is formed. Similarly, when it comes to Hubble or James Webb, I think when it comes to Hubble, there's a gigantic primary lens, and I don't remember what happens inside. Is there a reflector? Is there a prism? Is it another lens? But there are optical elements. In the case of the James Webb Space Telescope, okay, let's take a look at what it looks like. Let's put that on the screen. JWST, James Webb Space Telescope. So this is what it looks like. So you can see it's got a bunch. It's a compound mirror, and these are hexagonal mirrors all put together. And that light, whichever is collected on the mirror, is reflected into this smaller element, which will then process that. So let us say schematic. Schematic diagram. Do we have it? So yeah, if you look at this, it will tell you what are the components and how it actually works. So you have the primary mirror, 18 hexagonal segments made up of beryllium and coated with gold. There's a secondary mirror which gathers the reflected light, and then it gives that light to the primary scientific equipments, and these equipments, they all process the light and give you the scientific data, and so on and so forth. So that's how it works. So different telescopes work in different ways. You have Earth-based telescopes, you have space-based telescopes like Hubble, then you have the infrared telescope, which is James Webb. So the James Webb Space Telescope, so the Hubble Space Telescope, it primarily gathers light and data in the visible part of the spectrum. Whatever we see with our eyes is the visible range of the spectrum, and that's mostly the light spectrum in which Hubble gathers light and data. A little bit of infrared as well. When it comes to JWST, James Webb Space Telescope, it is designed to operate in the infrared range of the spectrum, because we want to be able to see the oldest light in the universe. And the oldest light in the universe comes from very, very far away, which is why it is highly stretched out. It is redshifted, and it is no longer visible to our eyes. It is so redshifted. So it is infrared light. So that's why the James Webb Telescope operates in the infrared uh, range of the spectrum, and that's why we've had to put it in orbit around the L2 Lagrange point in the shadow of the Earth. So that is very cool, and it is not impacted by light from the sun, and so on and so forth. So yeah, that's how it operates. To understand really how it operates, you have to see the schematic diagram and understand optics and understand various effects, and that's how it's done. And is it accurate? It's tremendously accurate. Of course it is. Otherwise, why would you spend so much money sending this instrument so far away and all that? Yeah. So it is indeed very much accurate.